Okay, hi. Now I'm gonna discuss first aid first aid review. Yeah, so this is actually just ano ba, my way of reviewing for the USMLE step 1. So I'm gonna discuss like the whole first aid book. And this is actually the book that I really have. I just took a picture and just post it in an app that can annotate it, and I'm just gonna discuss it. The purpose of this video or um, review is that to further enhance how I discuss the medicine topics, and it's actually for review purposes only. So here it goes. Okay, first and foremost, this is the first topic in the first aid reviewer. Um, the subject is biochem. First is the molecular. Then this is chromatin structure. Chromatin structure. So this is the picture of the chromatin structure. This is the euchromatin. This is the DNA. This is the euchromatin, DNA, nucleosome. And this is the DNA double helix. So here it says DNA exists in the condensed chromatin form to fit into the nucleus. DNA loops twice around the histone octamer to form a nucleosome. So DNA exists in the condensed chromatin form. So here's the DNA. And the DNA loops twice around the histone octamer. Here it goes. So it loops twice to form a nucleosome. So to form this nucleosome. So it is also called beads on a string. Ayan. So each one, this is the histone one, each one binds to the nucleosome and to linker DNA, thereby stabilizing the chromatin fiber. This is the histone or linker DNA. Yan, here. And then it binds, H1 binds in it. So this is the H1. Ayan. And then, so because of this process that happened here, it stabilizes the chromatin fiber. See, it stabilizes the chromatin fiber. And then the phosphate groups, so the phosphate groups is PO4. The phosphate groups give DNA a negative charge. So it gives DNA a negative charge. And then the lysine and arginine give histones, this one, give histones a positive charge. Ayan, a positive charge. I'm sorry for my handwriting. It's really not that beautiful. I don't have a beautiful handwriting, but yeah, that's how it is. So anyway, I'm gonna continue. So lysine and arginine give histones a positive charge. In mitosis, DNA condenses to form chromosome. DNA and histone synthesis occurs during the S phase. Diba? So in mitosis, DNA condenses to form chromosomes, and then DNA and histone synthesis. So in the S phase, this is in the DNA cell cycle, cell cycle. So there's an S phase there, and then during the S phase, this is where the DNA and histone synthesis occurs. Diba? So later, I'm gonna discuss the cell cycle. But first, ito muna. The next is mitochondria have their own DNA, which is circular and does not utilize histone. So this is What is special in mitochondria? They have their own DNA, and it is circular, and it does not utilize histones. So, ayan. So, for the next topics. In heterochromatin, this is the heterochromatin. So, this is condensed, appears darker on electron microscope. And so this is transcriptionally inactive and sterically inaccessible. It increase in methylation and decrease in acetylation. So there's a mnemonic here. So to better remember what heterochromatin is. So heterochromatin, HC, it is highly condensed. And the bar bodies, what are the bar bodies? These are the inactive X chromosome, may be visible on periphery of nucleus. The next is the euchromatin. This is less condensed. So to further remember it, more clearly, so diba, heterochromatin HC highly condensed while euchromatin is less condensed. So this appears lighter on electron microscope. So here it is, diba? Here, this is lighter. So see, compared to this, darker. This is heterochromatin and this is euchromatin. So this is transcriptionally active. Diba? If you will compare it with heterochromatin, diba? Heterochromatin is inactive transcriptionally while euchromatin is transcriptionally active, and this is sterically accessible while heterochromatin is sterically inaccessible. So here there's like a further information to further remember what euchromatin is. Eu meaning truly transcribed, and then euchromatin meaning expressed. Ayan, E. For the DNA methylation, this changes the expression of DNA segment without changing the sequence, involved in genomic imprinting. So the X chromosome inactivation, repression of transposable elements, aging, and carcinogenesis. So in DNA methylation, changes the expression of a DNA segment without changing the sequence. And it involved with genomic imprinting, and then X chromosome inactivation, repression, and transposable elements, aging, and carcinogenesis. So this is associated. This is associated with aging and carcinogenesis. Then DNA is methylated in imprinting. Methylated. Diba? Methylated meaning adding of methyl group. Diba? Methyl group, CH3. Diba? Methyl. That's one. Then, methylation within gene promoter, CpG island, typically represses or silences gene transcription. So there's this mnemonic that methylation M makes DNA mute because it silences gene transcription. So that's to further to remember it more and to understand it also. Methylation makes DNA mute meaning silent gene transcription. Okay, next, histone methylation usually causes reversible transcriptional suppression but can also cause activation depending on location of methyl groups. Histone methylation mostly makes DNA mute. So, diba, it includes methylation. So, when it includes methylation, it involves the the silencing of the DNA, right? But here it has histone. It it is with histone. So, histone methylation. So, in histone methylation, it just mostly make DNA mute, not actually make it mute, not make it mute all the time, but mostly. So, usually causes reversible transcriptional suppression. So, it is reversible transcriptional suppression, but can also cause activation depending on the location of methyl groups. So, it really depends on the location of the methyl groups. In histone acetylation, removal of histone's positive charge, relax DNA coiling, and increase in transcription. So, here, in acetylation, it removes the histone's positive charge that makes the DNA coiling relax. So, it makes relax, diba? Relax DNA coiling. And then, because of this, it increases transcription. So, because it increases transcription, it makes the DNA active. So, there's a mnemonic here like A, histone acetylation makes DNA active, while histone methylation makes most of the DNA mute because methylation mute, diba? Mute. And then acetylation active, it makes DNA active. Okay, in histone deacetylation, removal of acetyl groups tighten DNA coiling, and then this decreases transcription. So, removal of the acetyl groups, it tightens. So, di ba yung kanina, di ba, a while ago, there's a relaxed DNA coiling. And then, and that produces increase in transcription. While histone deacetylation, it is a removal of acetyl groups, so it tightens the DNA coiling, causing the transcription to decrease. Ayan. So, wow. First page pa lang. It's a lot of information na, but learning is fun. So, continue. Wow. So, for the nucleotides, diba? Here is the nucleotides. There is this term nucleoside. Nucleoside is base plus deoxyribose. So, deoxyribose is a sugar. So, nucleosides, SS. So, sugar. Because deoxyribose is a sugar. So, that's how to remember it. And then, the nucleotide, TT, diba? Base plus deoxyribose also. But, it also has a sugar, but a phosphate is added in it. So, phosphate has T on it. So, this is nucleotide. And this is linked by 3' to 5' phosphodiester bond. Okay. In the 5' end of incoming nucleotide bears triphosphate. 5' end of incoming nucleotide. Okay. In the 5' end of the nucleotide bears the triphosphate energy source of the bond. Triphosphate is the energy source of the bond. So, triphosphate bond is target of 3' hydroxyl attack. Okay. In the purines, it has AG, 2 rings. Diba? In the pyrimidines, CUT, 1 ring. So, there's a mnemonic here, pure as gold. Because purine, diba, what is included here is A and G. So, pure as gold. And then, for the pyrimidine, picat. So, this is a very effective mnemonic. Talaga. This is a very effective mnemonic. And then, thymine has a methyl in it. Methyl. So, deamination reaction, cytosine to uracil, adenine to hypoxanthine. So, if deamination occurs, cytosine becomes uracil, adenine becomes hypoxanthine, guanine becomes xanthine, 5-methylcytosine becomes thymine. So in GC bond, so this comprises of 3 hydrogen bonds. This is stronger. GC is stronger than AT bond because AT bond has only 2 hydrogen bonds. So, 'di ba? The more the merrier, okay? The more the stronger. The more the hydrogen bonds, the stronger it is. GC bonds has 3 hydrogen bonds while AT bond has only 2 hydrogen bonds. So, clearly GC is stronger than AT. So, increase in GC content means it increases melting temperature of the DNA. So, increased melting temperature, that means that it is not easily destroyed, it is not easily melted. So, for example, the melting point is only like 100 degrees Celsius, but if it is GC bond, it would probably be 120, like that. So, it is increased melting temperature of DNA. In the 120 degrees Celsius, that is only the time that the GC bond will melt. So, that's just an example. That's not the exact amount, but just an example to show what increased melting temperature of DNA is. So, there's a mnemonic here. CG bonds are like crazy glue. So, uracil found in RNA, thymine in DNA, methylation of uracil makes thymine. Uracil found in RNA. Thymine is found in DNA. Oh. So, UR, diba? And TD. UR, TD. Thymine in uracil. I think, this can be remembered by looking at this, diba? Uracil, UR, so RNA. Yeah, that's a good mnemonic. RNA, ayan. So, the other one, thymine, TD, diba? DNA. Tidy, like that. So, anyway, in methylation of uracil, when the uracil is methylated, it makes thymine. Nice. Okay. And then amino acids necessary for purine synthesis. These are the amino acids necessary for purine synthesis. Glycine, aspartate, and glutamine. CAG. So, there's a mnemonic here. Cats purr, meaning purine, purr until they gag, like vomit. So, gag, meaning glycine, aspartate, and glutamine. Okay? Wow, I'm learning. I'm really learning. This is so effective. I'm gonna continue. So, there's a part 2 later. So, nice. But I really enjoy this. So, later na ulit, I'm gonna post like part 2 of this lecture. I'm really enjoying this. I'm learning a lot. Biochem is really not the subject that I would like boast of being good at. But I think with this, I have the shot of being good at it. Okay? So, I'm gonna continue later. Bye.